this one, so we have hydrogen peroxide entering at 50%, exiting at 3%. Don't know the initial volume, but you know the final volume of 20 gallons. And the initial and final density are different. So in this case, this is a dilution, and actually use the word, I think, diluted in there. So that's a big hint that you're going to use this formula. Okay. So the initial molarity is going to be the 50%, but we'll want to, it's not in the right concentration units, so we'll change those. There's the final polarity, again not in the right concentration units. We want to know volume 1. We know volume 2. Is that? So it's a combination of a lot of conversions with a dilution problem. Okay? So that's this concept or idea of it. Now let's start. 50% by mass means 50 grams of the H2O2 for every 100 grams of the solution. So when you go backwards, that's how you go backwards. But we want it in molarity, so we want moles on top, liters on bottom. So let's start with the top first. We need to use a molar mass, 34.01 grams per mole, I believe, for H2O2. Let me double check that. Yeah, 34.01. So that puts moles on top, halfway there. Now we need liters on the bottom. And we can do that with the given density for that solution, which is 1.197 grams per centimeter cubed. So that'd be grams of solution that cancels, and now we'll have, and I think it's per, well these are all per milliliter. Milliliter and centimeter cubed are the same, but I think the problem gave it in milliliters. We'll change that. It doesn't really matter because they're the same, but it'll be easiest for us to use milliliters. Yeah, it gave it per milliliter. Okay, and then there's just one more step. I don't want milliliters down here, I want liters. So it's 10 cubed milliliters per liter. And so now all I'm left with is moles per liter for the 50% solution. And that turns, let's see if I have that number for us. That's 17.6 molar. So that turns out to be 17.6 molar. Okay so far?
Yeah.
Okay. Do you want me to write out the 3% one? Or do you want me to just give you the answer?
So you just find the exactly 3% over 100 grams.
Right, yeah, so you put 3 here. I guess that'd be the same. This would be this number. That'd be the same.
Got it.
That turns out to be 0.9 molar. So this is, I'll put it up here, 0.90 molar. 0. So that's okay? So we're converting. So you want to be able to go between percent mass and molarity. What else do I have? I can convert to, well, for volume you can do it one of 2 ways. As long as the volume units match up, you don't have to convert from gallons. You could. So you could either go from gallons to liters if you want, or just leave them both in gallons, or whatever the unit is, as long as they're the same. So they could, both volumes could be in milliliters, both volumes could be in whatever. Meters cubed, it doesn't matter. As long as they're the same, you're okay. And I believe the answer desired is in gallons. Is that okay?
Yeah.
Okay, so you'd set up the equation, M1, 17.6, V1, well, that's what we're solving for, M2, 0.90, V2, 20 gallons. Now when you solve for V1, let me see if I have that number. I get 1 gallon. So V1 you should get 1 gallon. Now let's read the question to see if how many, the question was, how many gallons of water does the engineer need to add to the 50% solution in order to get a 3% solution? Well, if this turns out to be 1 gallon, then I need to add 19 gallons to get to here.
So 21.
Yeah, so V2 minus V1, which would be the gallons added, will be 20 minus 1, or 19 gallons, which is your answer. Again, you could have converted gallons to liters and then converted back to gallons, but it doesn't matter for the